Calculus, Unit 7, Day 62 notes. Our objective is to be able to find the area between two given curves. Okay, so graph the function f of x equals negative 1/2 x squared minus 2x plus 4 and find the value of the integral from negative 5 to 0 of f of x dx. Using one color, shade the region for which this value represents the area. And again, finding the area between two curves is just an application of integration. So right here I have a parabola. It's opening down. One way to help me start is I know it's going to have a vertex, which it's opening down, so that point will be a maximum. Let's take the first derivative of that function, which is negative x minus 2, set it equal to 0. And so when x equals negative 2, that's going to give us our vertex, which is the maximum. So I can substitute negative 2 in there, and then I can put some other points in. So let's go ahead and do that. Okay, so I put in negative 2 and I find that the vertex is negative 2, 6. Find some other points, and then from negative 5 to 0, this is the shaded region. Well, now I want to also find this value of the integral. So I'm going to go through, write the function. Now I'm going to take the antiderivative. So that's negative 1/2 x cubed over 3 minus 2x squared over 2 plus 4x to the 1. I'm going to simplify it, and then obviously I'm going to simplify that, but then I'm going to evaluate using the fundamental theorem of calculus. And we're going to get some decimals here. So every place I see an x, I put in 0. Obviously that's going to be 0. Then I subtract that from the lower interval, which would be negative 5. And I'm going to give you this value. This comes out to 24.167. Okay? Now they're going to ask us, graph the function g of x equals 1/2 x plus 4 on the same grid above, and then find the value of the integral from negative 5 to 0 of g of x dx. So doing the same thing. So use a different color. So let's first graph that and shade in that area between the graph and the x-axis. So there's the graph of the line, and in black that's the shaded region. So that represents the integral from negative 5 of g of x dx. All right, let's actually go through and find that, taking the antiderivative and then evaluating using the fundamental theorem of calculus. So let's first just write in g of x and d of x in there. Let's go through and take the antiderivative. Okay, let's simplify, and now I can evaluate. Let's put in those values. Put in 0, so it's going to be 0 minus, let's put negative 5 in everywhere, and then I'm going to get an answer of 13.75. Okay, and now the next question says, what do you suppose you would do to find the area of the region that is located in between the graphs of f of x and g of x? Find this value. Well, I'm going to take the entire value, which was in green, and I'm going to subtract what's in black. So what's left over should be between the two curves. I'm writing in blue. So let's go back and answer that question. What do? I'm going to subtract the area between f of x and g of x, take those two values. So in blue, I'm going to get an area of 10.417. And that's really our main goal of this unit. Okay, so that's 10. So take the whole thing and then take away the part below, and then this gives me everything in between f of x and g of x. All right, let's try the example in the next page. Okay, so now we're going to look at the same two functions and just say, what if I just subtracted them? So we're not looking at the graphs, we're not treating them separately. So if we had the integral of f of x minus g of x, well, then I could, the integral of two different functions, I could first simplify those functions. Negative 1/2 x squared stays the same. Negative 2x minus 1/2 x is negative 5/2 x. The 4's cancel out. So now let's start taking the antiderivative. We're going to evaluate with the fundamental theorem of calculus, but let's simplify this first. Okay, and now when I put in the upper interval first, I'm going to get 0. And then when I put in negative 5 to replace c and x, let's do that on the calculator. And notice what we get. We get the exact same solution. So let's write that down in the next step. So what do we notice about this? The integral from negative 5 to 0 of f of x dx minus the separate integral from negative 5 to 0 of gx dx, which we found to be 10.417 on the left side, is going to be equal to the integral from -5 to 0 of the difference of the two functions. So we found this to be 10.417. So the same thing. So what does this bring about? Okay, area between any two curves f and g of x is the integral from a to b of f of x minus gx dx, where x and a are the x coordinates of the points of intersection of f and g, and where f of x is greater than g of x. So it's always which one is above the other one. So, and there's going to be times where one function's above from, so 1 to 5, but then from 5 to 9, the other function's above, and we're going to learn how to do that in some of our next examples. Okay, so let's turn over to the next example.